Class, welcome to our second part of lesson 3.1 that deals with radian measurement. We're going to go through some exact value questions again and a few questions dealing with a clock and determining how many degrees and or radians that it's rotating. So make sure that you're still good with the times pi over 180 to get into radians or times 180 over pi to get it into degrees. First questions we're going to look at are just some review things with exact value. Remember, use the pi over 6. Okay, in this first question, pi over 6 will determine the reference angle of 30. And so sine of 30, the reference angle should be 1/2. The only issue is if it should be negative or positive. It's in quadrant 1 because 13 times 30, there's 13 pi over 6s or 13 30s, that's 390. That's one time around the circle and then 30 left over, which is the same in quadrant 1. So it's positive because everything's positive in quadrant 1. In the second one is cosine of 3 pi. Remember, pi is 180 because that's the whole idea of multiplying by pi over 180 to get things into radians. 3 times 180 would be 540, which is the same as 180. Remember, these quadrantial angle spots, you probably need to use the circle idea, okay, with the ones and zeros, or you could use the graph of sine and cosine. If I use the graph at 180, it's -1. If I use the x and y, it's -1 because the x value here is -1. Either way would work for that question. Next thing we want to look at is just rotating, and the key thing is about how fast the hands of a clock are rotating through. So the hour hand of a clock goes all the way around the circle one time in 12 hours. So it makes sense here that in 12 hours it should be 2 pi or 360 degrees, because that's one time around. In 3 hours, think about it as if it started at 12 o'clock and then it went to 3 o'clock. That's 3 hours, okay? And that's 1/4 of it, or 90 degrees of the circle. And that also could be written as pi over 2. Remember, they want radians here, so you don't want to write the answer in degree format. You want it to write it in radian format. The next question deals with the minute hand. And remember, the minute hand goes around one time every 60 minutes. So if you ask for 12 hours, the minute hand is going to go 12 times around, 12 times 360 or 12 times 2 pi, and that's 24 pi. In 3 hours, it's 3 times 2 pi or 3 times 360, and that would be 6 pi radians. And remember, it's just because that minute hand goes around in 60 minutes, one time around the circle. The minute hand now rotating in 45 minutes. So it's 3/4 of one time around the circle. And the reason it's 3/4 is it's 45 out of 60. You could start this out as 45 over 60. That actually might be helpful because on the second question, notice it's 37 minutes and it's 37 out of 60 here because it's 37/60ths of the hour. In both cases, though, you need to simplify when you can, and probably in these cases you'll leave answers in terms of pi with a rational number out front or an improper fraction. So you want to make sure that you're looking at that for that situation. One typo here, this should be a 37, not a 57, so sorry about that. So 37, okay, in that spot. Okay, back to exact values. Remember, pi over 3 is 60 degrees. It's in quadrant 1, so sine of 60, opposite is √3, adjacent, or hypotenuse, excuse me, is 2, and that's your answer. Cosine of 5 pi over 6 is 30, so I can figure out the ratio right there. Adjacent to 30 is √3 over 2. It's actually the exact same triangle as this one, because notice they're cofunctions. 60 for sine is the same as 30 for cosine. The only difference is this one's negative because it's in quadrant 2. And since it's in quadrant 2, all students take calculus. Sine is positive in quadrant 2, but cosine and tangent are negative. Next, cotangent of 7 pi over 6. Pi over 6 again is 30 degrees. Okay, that's the one you want to know. 7 times 30 degrees would be 210, and that's in quadrant 3. So opposite over adjacent would be tangent. So adjacent over opposite would be cotangent. And the adjacent at 30 is 3 over 1, which is √3. And it's positive because in quadrant 3, tangent and cotangent are positive. Cosecant of pi over 6, but it's negative pi over 6. Notice this is the same as negative 30 degrees, but in quadrant 4, because remember you're starting here at the normal spot and going down 30 degrees. Sine of 30 would be 1/2, but you got to flip it, so it's 2 over 1. Remember, you don't need the over 1 in your answer. And it should be negative because of the fact that it's in quadrant 4. I know I'm going through some of those fairly quickly, so make sure you understand where they're coming from. I would just have a 30, 60, 90, and 45, 45, 90 triangle off to the side. You can keep using that. Some of you have a chart also with some of those reference angles written out. I think that might be a good idea as well. Next one, sine of 21 pi over 4. Pi over 4 automatically 45 degrees, and that's an easy one with sine and cosine because they're the same. So it's root 2 over 2, which started out as 1 over root 2. And times 24 is 945. I'll leave it to you to figure out kind of why it's quadrant 3, but it deals with going around the circle a couple of times. And sine should be negative in quadrant 3. Cosecant of pi. Pi is 180. That's a weird spot. That's a quadrantial, so you either have to use the x, y coordinate or the graph of sine. Either way, you should get 0 because it hits the x-axis, or the y value here is 0. And when you flip that, though, that's when it's undefined. I think some of you are assuming every time there's a 0, it's undefined, but that's only when the 0 is on the bottom. Sine and cosine shouldn't be undefined. It should be secant and cosecant that are undefined. Tangent of 2 pi over 3. Pi over 3 is 60 degrees for the reference, times 2, that's quadrant 2 because it's 120. At 60 degrees, opposite is root 3, adjacent is 1, but it's negative because in quadrant 2, tangent is negative, and you get negative root 3 as your answer. Cosecant of 5 pi over 6. Pi over 6 is 30 degrees. 5 times that would be 150, so that's in quadrant 2. And sine of 150 actually is pretty similar to this sine question here, this cosecant one. So this one was negative 30 degrees, and it was negative 1/2 because it was in quadrant 4. So ours is similar, but it's positive because it's in quadrant 2, and then cosecant would be its reciprocal. Okay, that's everything for this lesson. Just make sure that you're okay with exact values. There should be a lot of root 3s and root 2s. Be careful with this undefined piece as you're looking at it. And then also the minutes and hours, just make sure you know how long it takes for one rotation around the circle, and then make a fraction out of that. And also don't forget this is 37, not 57. Sorry about that mistake. Have a good day, everybody.